over to you.
The slides visible?
Ji.
Right. Assalamu alaikum. This is Qazi KeepTruckin, and today I'm here to present my final year project's mid presentation. So the title of my project is Simultaneous Object Detection and Tracking, which will be a fast and accurate detector and tracker. My supervisors are Dr. Detector from Novel and Dr. Ejaz from KeepTruckin. He's a senior research scientist over here. So what is the problem statement? Basically, we need a fast, lightweight, and accurate detector and tracker that can work in real time on edge devices. So what is edge device? We all know, like a mobile phone or a camera. All the detectors and trackers are like heavyweight models, and they can't be deployed on the edge devices. And basically, this is required for the KT team, which have AI cameras on which they can deploy the models for real-time detection and tracking. Currently, they are using mobile net SSD and for detection only. But now, in my FFP, I'm trying to use YOLO along with some sort of tracking mechanism, which will detect and track the like it will build a complete trajectory of the object. So I will start with detector part. So my first part of this project was detector. So what is detector? Basically, object detection comprises of two parts. Localize the object first in the frame and classify, like find the location and add a label of the class. So this is basically a difference between the classification and object detection. On the left hand side, we can see there is a classification model in which we feed the image and we get a result like this is a cat or a dog. But in detection, we get a bounding box over the detected object. That is, we find out the location of the object along with the category to which it belongs. So basically, we can say that it is localizing plus classification pipeline, which is very complex than classification. The first part of my FAP was like an intensive research on all the detectors which can do the real-time work for me. So I started with the two types of detectors, which is basically two-stage and one-stage detectors. Two-stage algorithms contains RCNN, faster RCNN, and the one stage includes YOLO and SSD. One stage are obviously very fast as compared to two-stage. The reason is this: two-stage detectors two-stage detectors first apply an algorithm which proposes the region of interest. Like it proposes, it can be an object, this location can be an object, and then run a separate classifier on each of the location and presents its results. In the next slide, this is basically the architecture and the working of RCNN, which is a two-stage model, and it is a complete family of regions with CNN family. So what this it does is simply inputs an image to the model. We apply a selective search, which is basically a segmentation algorithm. It can be used from the OpenCV, which basically extracts 2000 regions based on the color segments and then wraps it up, because we are using a convolutional network here and it has fully connected layers. So it means we should have a fixed input size. So we take the region and wrap it, like if this is a LXNet, so we will wrap it to 224 cross 224. Then we will run the classification model over it, and each region is basically classified. So this is the like pipeline of it, and it takes almost 40 seconds to basically process a single image, because it is obvious if we are extracting 2000 from the single image and then passing each region separately through this network, it will take a huge amount of time, and it is not end-to-end trained. What we do is we just pick the CNN model and train it over these regions first. Once it is trained, then we simply apply this. We simply take the image, apply same hard-coded algorithm over it, like extract the regions and pass it through this. And then after this, we apply non-max suppression, which is basically selecting the highly confident box and removing all the suppressant box, like just a confidence low. I can move ahead, I think. So The second pipeline is one-stage detectors, which are the end-to-end models which can be trained and give the inference in a single run. And it is YOLO. You only look once. So what is YOLO? YOLO is basically you look only once. This is the architecture of base YOLO V1 version, which actually contains 24 convolution layers. And at the end, we can see there is basically these are not the convolution layers at the end. They are the fully connected layers, but they are resized to 7 cross 7 cross 30. What is this? I will explain it later. We can see here over here that there is an image input, and after it we got some sort of bounding boxes, and at the end in the second half we can see there is some sort of class probabilities. Then we apply the non-max suppression, like in simple words, this is pick all the bounding boxes and select a maximum bounding box which has highest IOU value, like 0.9% confident, and then loop over all the detected bounding boxes, compare it with the selected one. If any object has maximum match with the already classified bounding box, then remove this object, remove this bounding box. So that will give a clean representation which is presented on the right hand side. This is the architecture of YOLO V1, which is complete end-to-end convolutional neural network, contains of two fully connected layers, and it can be trained and do the classification work. These are the convolution layers, and image size is fixed. Input size is 448. It should be fixed because we are using fully connected layers, and there are a bunch of convolution layers and filters to reduce the feature dimension to 7 cross 7. Basically, this 7 cross 7 is a grid size, which I think I will explain in the later half when I will be explaining YOLO V3.
Qazi, एक clarifying question है.
Yes, sir.
यानी contrasting between stage 2, यानी 2 stage versus now a single stage में वही काम हो रहा है ना, लेकिन दोनों CNN ही use कर रहे हैं eventually. तो what lets this YOLO get rid of the जो first stage था पिछले वाले जो architecture में, जिसमें वो पैचेस, राइट, जो इंटरेस्टिंग पैचेस हैं विद इन अ सिंगल इमेज, वो जो आप सेगमेंटेशन कलर की बेस पे या किसी और तरीके से एक लेयर पहले चलती थी ना स्टेज 1, तो जबकि दोनों ही CNN यूज कर रहे हैं, राइट, तो व्हाट लेट्स YOLO गेट रिड ऑफ दैट स्टेज?
Right, sir. So YOLO basically transformed this classification pipeline to regression based. Now that's a bit complex. उसमें ये था कि जो इसकी end layers लगी हुई हैं convolution layers के बाद fully connected layers, they are basically predicting the actual bounding box coordinates. But जो previous approach थी, they were extracting the regions and then passing through the classification network. But जो ये network है, ये basically classification भी कर रहा है, plus इसका जो end है वो regression वाला काम भी कर रहा है. So that was the difference between them.
Wonderful, right.
Now this is IOU. IOU basically means ke intersection over union. जैसे कि when we train the model, we get some sort of like loss function or this आपको कितना accurate आपकी predictions आएंगे. So जो होती हैं ना ये detection वाली pipelines, we basically get a predicted box and we have a bounding box which is the ground truth. So we simply take the IOU, basically the area of the overlap and the area of a union. It gives us a value between 0 and 1, the similarity matrix we can say. So if we have a high IOU, it means our prediction is well matched with the ground truth. And if we have a low IOU, it means it is a bad prediction. So the journey of YOLO family, it started from YOLO V1 up to YOLO V3. It was basically by Redman, which is a research scientist. But after that, he stopped the development of YOLO V3 and completely backed off from it. And its implementation is available in its pre-DG repository, which is basically implemented in darknet. After that, LXAB came up and presented a YOLO V4 version, which was more accurate and faster than YOLO V3. And right after this, YOLO V5 came, which was a game changer. And I'm basically using YOLO V5 now. I have added some sort of things regarding YOLO V3. YOLO V3 came after YOLO V2 because YOLO V2, YOLO V1 suffered from the sorry, localizing and detecting the smaller objects, because uh, उसके बाद कुछ था कॉन्टेक्स्ट ऑफ ऑल द इमेज, बट हुआ ये था कि वो 7x7 की ग्रिड अप्लाई कर रहे थे एंड दे वर मिसिंग minor details क्योंकि 7 if the image is of 414 448 cross 448 and we are only taking 49 points, 49 boxes, so we are just taking 98 bounding boxes, which was a less amount. So YOLO v2 came and presented another approach, and they started using 13x13 grid, but still it was lagging state of the art accuracy. So YOLO v3 came after that. It uses some new mechanisms like introducing of using no fully connected layers. It was a completely convolutional network, and they took detections at 3 scales. It contains of 106 layers, and they introduced upsampling layers and skip connections. And on Titan X, it was these stats are taken from the YOLO v3 paper. YOLO v2 ran on 45 FPS on Titan X, but YOLO v3 ran on 30 FPS on Titan X, but still it was more accurate than YOLO v2. The main thing was they used a pyramid-like structure, which is explained later. First plus point was that we can input any input size of image because we are not using convolutional fully connected layers. So we can input any size of image, but we will use those image sizes which are the multiple of 32 because we are giving a slide of 32, 16, and 8. So it has a backbone architecture. You can see on the left hand side, there are 53 convolution layers which contains residual blocks. Now, what is this block? It is very simple concept. If we have 3 convolution or 4 convolution layers, and we are picking the output of first convolution layer and then concatenating it after a few layers to get like to take the feature map from the previous layer to the forward layer. This helps in reducing the gradient vanishing problem, because if we have a very deep network and we don't have this kind of things, like if you're not taking the input from the initial layers and concatenating it to the later layers, we are losing the dimensions. So preserving to preserve the feature dimensions, they introduced a concept of residual blocks from the resonate architecture. Now at the layer number 79, we can see there is a first detection head, which is strided by 32. It means if we have 416 416 cross 416 image and we divide it by 32, we will get 13 cross 13 grid, and each grid cell over the image will be responsible for predicting an object. Now how YOLO works, it's simply, if I can move to the next slides, then I will come to it later. So this is an image. It is divided into 13 cross 13 grids after 82nd layer of the model. Now, if we consider the first cell, here the YOLO predicts 13 cross 13 cross 255. Now, what is this? 255 is basically a depth. It's a depth which contains 3 bounding boxes along with the class predictions. So it was trained on COCO dataset, which consists of 80 classes. And each bounding box needs 5 coordinates like x coordinate, y coordinate, which is the central points of the object, and height and width. And height and width are basically the height and width of the predicted bounding box. So this is a simple like vector which every cell produces. Now, at the first scale, it predicted its output, and then after it, we just upsample it. Like if it is 13 cross 13, we upsample it to 38 cross 16 ka double 32 ho jayega. Then we take a feature map from the previous layer, which is 61 layer. It is also of the same dimension, and just add its depth dimension, like 255 plus 255, to have a context from the previous layers as well. Similarly, it upsamples and predicts on the larger scale, and again at the further larger scale. So if the grid size is very large, it means it can predict smaller objects as well. I hope its structure is a bit clear.
अच्छा काजी, वो जो फर्स्ट रेजिडुअल ब्लॉक था उसमें यू
Yes, sir.
सेड फीचर मैप्स कनकैटिनेट हो रहे हैं, वो प्लस वो आई
Yes.
गेस डिपिक्टेड बाय प्लस है ना?
Yes, sir.
बट ये जो 61st लेयर आगे चली गई अप स्केल करने के बाद, बट वहां पे प्लस नहीं हो रहा ऑपरेशन, इफ यू लुक क्लोजली वो मल्टीप्लिकेशन है. सो व्हाट डज दैट मीन?
राइट सर. सर प्लस में पूरा का पूरा फीचर मैप आपस में ऐड हो रहे थे उनके डायमेंशन के साथ. जो मल्टीप्लिकेशन है कंकेटिनेशन में, इसमें सिर्फ डेप्थ को उन्होंने आपस में मल्टीप्लाई किए हुए, इसलिए पहले उन्होंने अप सैंपल भी किया वैसे, क्योंकि इसकी जो डायमेंशन थी वो उससे कम थी. देन उसको अप सैंपल करने के बाद 13 × 13 से डबल कर दिया है, और फिर जो प्रीवियस लेयर थी यहाँ से फीचर मैप ला के ऑफ सेम डायमेंशन उसकी डेप्थ को आपस में ऐड कर दिया गया. तो वो पूरे फीचर्स मैप आपस में ऐड हो रहे थे, यहाँ पे सिर्फ डेप्थ ऐड हो रही है.
राइट, तो इसलिए वो मतलब वो उधर प्लस क्यों नहीं यूज किया इन्होंने? मैं तो प्लस और मल्टीप्लिकेशन डिफरेंट ऑपरेटर्स हैं.
सर वो आई थिंक जो है ना रेजनेट यूज करता है आर्किटेक्चर, वो करता होता है रेजिडुअल ब्लॉक वाला. तो उसमें हम सिर्फ एडिशन करते हैं, लेकिन यहाँ पे अप सैंपल करने के बाद सिर्फ वो डेप्थ को आपस में ऐड कर रहे हैं. तो आई थिंक दैट्स द डिफरेंस बिटवीन देम.
राइट, ठीक है, आगे लेट्स मूव ऑन.
ये भी हो गया. So the reason is why I am not using YOLO v3 for my task. Yes, it is accurate, but it is not fast, which I will show in the demo, which I will run in my laptop after a while. It first constraint is of speed, and second one is it is a heavy and complex architecture, but it is relatively less complex than YOLO v5. So YOLO v5 is the current state of the art object detector. The interesting thing about YOLO v5 is that it has no research paper with it. It was introduced by Glenn Jocher under his Ultralytics GitHub repository. Basically, he implemented YOLO v3 in PyTorch. Then, in the process of incremental improvement, he just released his YOLO v5. YOLO v5 after this. So YOLO v4 was presented by Alex AB, and YOLO v5 was presented by Glenn Jocher. It is completely written in PyTorch. It comes with different model versions like v5x, which is the like heaviest model, and the lightest version is YOLO v5n, which is only which contains only 1.9 million parameters as compared to large one which contains 38 million parameters. You can see in the 8th bullet, YOLO v5s, which is the second last, like not the smallest version, still it is 90% smaller than YOLO v5. Its weight file is about 27 MB, and YOLO v4 weight file is 244 MB. It is fast as compared to YOLO v4, but I think it will be a bit less accurate as YOLO v4 is a complex architecture. This is a graph taken from the Ultralytics website. So what it depicts is very simple. On the x-axis, we can see speed, which is GPU speed, milliseconds per image, and on the left-hand side, we can see a mean average precision value. So object detection has a evaluation matrix which is mean average precision. What it does, it takes the precision and the recall, and then for each class, like if there are 10 classes, it will calculate average precision for each class and then will take a mean of it. It will give a mean average precision. So this is the evaluation matrix of the detectors. And we can see on the left bottom corner, YOLO v5s has a great speed in terms of has a very great speed as compared to YOLO v5l, but it is a bit less accurate. YOLO v5 is available in the Ultralytics. Fair amount of documentation is available, and open source hai, open from modifications hai, and I have changed few things in it, which I will show. I will show the results after it. This is basically YOLO v3 inference on CPU. This is an image given in their repository. I have tested it in the darknet framework on using my CPU. It took 19.16 seconds to predict this box. The time is a bit high as it is darkened framework, and it takes like इसकी अपनी कुछ complexities हैं, heavy framework है, but accuracy देख सकते हैं आप इसकी, it is very much confident कि वो ये objects हैं. After that, I ran YOLO v5n on the same CPU, and I have calculated the FPS from this. As we can see, 2.2 milliseconds for pre-processing the image, 44.7 milliseconds for the inference speed. Inference is basically when the model does its predictions, and 1.2 is the non-max suppression, which is the post-processing of the bounding boxes. And it took 20, it is working on 22 FPS, and the image was this. It is a video which I captured in local, like in Namal area, and it is that prediction which is the model predicted. So what's
अच्छा वो
next?
YOLO V3 का लोडिंग द वेट्स तो एक्सक्लूड करके था, ये जो प्रेडिक्टेड
Yes.
टाइम है प्रेडिक्टेड इन 10 सेकंड्स.
नो सर, वो इसमें इंक्लूडेड था. मैं उसको उसके बाद भी दिखा सकता हूँ आपको. मैं इट विल टेक अराउंड 6 seconds. मैंने बताया था ना कुछ इसमें डार्क नेट के फ्रेमवर्क की भी कुछ लिमिटेशंस थी. इसको मैंने लोकली भी लोड किया है इन कैरास के अंदर.
अच्छा.
तो उसने 6 सेकंड लिए थे फॉर इन्फ्रेंस.
माइनस द लोडिंग ऑफ वेट्स
यस,
टाइम.
जस्ट इन्फ्रेंस टाइम.
ठीक ठीक.
और ये इसका लाइक इन्फ्रेंस टाइम है जो कि मैंने कैलकुलेट किया हुआ है. So that was the detection part. And now what is left is the tracking part. Currently I am experimenting with two things. Like the maximum target है वो ये है कि somehow I am able to attach LSTM in this complex architecture which is YOLO V5, which is a challenge in itself. I am exploring this thing. काफी टाइम हो गया इसको देखते हुए, लेकिन अगर ये हो गया तो it will be a unified model which will be detecting and tracking. If ये ना हुआ, then the second approach is basically IOU thresholding. Now what is IOU thresholding? As a video जो होता है is a sequence of frames. If I have detected the object in the first frame, I will run the detector on the second frame again, and I will get the detections. And then I will compare the previous detection with the new detections. If they have 90% or 80% similarity in it, I will say this bounding box is the same which was previous, so I can build a trajectory on it. So that this is a thing which I will explore
तो ये
ahead.
डेफिनेटली पोस्ट प्रोसेसिंग है.
Yes, sir.
तो किसी तरीके से ये IOU का जो फार्मूला भी क्योंकि नॉन है, वो लॉस फंक्शन में नहीं कन्वर्ट किया जा सकता वाइल ट्रेनिंग.
सर IOU का जो फॉर्मूला है वो बेसिकली लॉस फंक्शन ही होता है इसका, जब वो
नहीं,
बाउंडिंग
यानी कि
बॉक्स का.
इंस्टेड ऑफ कंप्लीटली आर्किटेक्चर डिटेक्टर का, राइट, आप तो फ्रेम बाय फ्रेम डिटेक्शन कर रहे हैं ना अभी.
यस.
और फिर आप ट्रैकिंग के लिए यूर एडिंग अ पोस्ट प्रोसेसिंग टाइप लेयर, है ना, जो कि
यस सर.
इन्फ्रेंसिंग सिर्फ करा रहे हैं वंस द मॉडल इज ट्रेंड. उसके उसके ऊपर पोस्ट प्रोसेसिंग की एक आप IOU बेस्ड थ्रेशोल्डिंग की लेयर लगा रहे हैं ना. आई एम सेइंग कि अगर आप इंस्टेड ऑफ डूइंग इट दिस वे, अगर IOU की बेस पे कोई CNN का ही, यानी ये योलो V5N का लॉस फंक्शन IOU की बेस पे सोचा जाए और फिर उसको ट्रेन, तो इट विल बी वन पाइपलाइन,
यस.
राइट.
राइट, लेकिन सर उसमें ना एक इशू आएगा ऑफ मेमोरी. हाउ विल लाइक उसमें याद कैसे रखेंगे कि जो प्रीवियस था ये वही सेम है. इसका इशू होगा. उसके लिए हमें आई थिंक LSTM चाहिए होगा फिर.
राइट राइट राइट. उसके लिए वो फिर जो सियामीज टाइप हम डिस्कस कर रहे थे कि एटलीस्ट
यस.
वन प्रीवियस फ्रेम, यानी कि आपकी एक इनपुट की बजाय दो इनपुट्स जाए टू द होल पाइपलाइन.
यस
बट लेट्स डिस्कस दैट ऑफलाइन.
श्योर सर. सर शुड आई मैं कुछ डेमो दिखा दूं इसका, वीडियोस वगैरह?
जी जी प्लीज.
ओके. Where is the meeting? Just 1 second. सर मैंने फिलहाल ये अभी किया था कि इसकी मैंने रिपोजिटरी को मॉडिफाई किया है, और मैंने किया ये है ना कि जो योलो V5 लार्ज है वो एक्यूरेट है एज कम्पेयर टू योलो V5N। सो मैं अपनी अनलेबल्ड वीडियोस उसको दे रहा हूँ एंड इट इज जनरेटिंग लाइक डेटा सेट फॉर मी। उसका रीज़न ये था कि इफ अगर मैं योलो V5N को यूज़ कर रहा हूँ तो वो थोड़ा सा लेस एक्यूरेट है। सो एक हाइपोथेसिस हमारा ये था, अगर हम योलो V5 की आउटपुट ले लें, उसके ऊपर IOU थ्रेशोल्डिंग करके एक डेटा सेट जनरेट कर लें ट्रेजेक्टरी बेस का, और फिर योलो V5N के साथ LSTM अटैच करके उससे ये डाटा दें, तो इट विल लाइक वो फिर एक सिंगल पाइपलाइन बन जाएगी इसकी। उसके लिए मैंने ये चीज़ें की थी। उसका अभी तक हाफ पार्ट इम्प्लीमेंट हो चुका है, जो कि मेरा मुझे लेबल्स जनरेट करके दे रहा है इस तरह के। और उसमें क्या है कि ये उसका क्लास लेबल है, और ये इसके एक्स फाइल लेबल्स हैं, और ये वेक्टर उसकी हाइट है। और सिमिलरली अगर वो ऑब्जेक्ट डिटेक्ट करता है तो साथ उसका वो फ्रेम भी कैप्चर कर लेता है, उसके साथ सेव कर लेता है विद सेम नेम। अब एक जो वीडियो है ये मैं आपको दिखाता हूँ। ये इसके योलो V5 लार्ज के रिजल्ट्स हैं। इसकी स्पीड वीडियो की सेम ही रहेगी, क्योंकि ना वो फ्रेम्स को काउंट नहीं कर, वो प्रोसेस करने के बाद दोबारा से वीडियो को सेम फ्रेम में कन्वर्ट कर रहा है, लेकिन इसकी इन्फ्रेंस स्पीड स्लो है एज कम्पेयर टू योलो V5N। तो ये जो लोकल वीडियो मैंने रिकॉर्ड की थी उसके ऊपर है। जो साथ ये स्कोर शो हो रहे हैं, दे आर बेसिकली लाइक यू कैन से कंडीशनल क्लास प्रोबेबिलिटी, कि अगर तो इफ देयर इज एन ऑब्जेक्ट एंड वो फिर साथ में उसका क्लास लेवल भी प्रिडिक्ट कर रहा है, तो फिर उसका आपस में दोनों का लाइक जो होता है ना कंबाइन करके, वो उसका स्कोर है कि ये 0.8% कार है।
राइट, तो इट्स प्रीटी गुड। बस ये कि वो ऑब्जेक्ट्स लूज हो रहे हैं ना, यानी ट्रैकिंग नहीं हो रही अभी, सिर्फ ये कि डिटेक्ट हो रहे हैं अभी फ्रेम पे ना।
ये सर ट्रैकिंग हो रही। सर इसका एक और प्रोसेस भी था कि वो जीरो शॉर्ट लर्निंग का एक एल्गोरिदम है, जीरो क्लिप एल्गोरिदम, जो कि ओपन एआई ने प्रोड्यूस किया हुआ है। तो वो भी इस साथ अटैच हो सकता है, इसकी वो रोबोफ्लो ने उसकी इम्प्लीमेंटेशन दी हुई है। तो वो भी साथ में एक्सप्लोर करूंगा, इफ दैट थिंग वर्क्स तो वो भी इम्प्लीमेंट हो सकता है। अदरवाइज LSTM वाला जो सिंगल पाइपलाइन है वो एंड गोल है।
अच्छा, तो ये जो आपने रिजल्ट दिखाया है, ये V4 का है या V5
नहीं
का
सर,
था?
ये V5 का है लार्ज,
लार्ज
उसका
का,
एक्यूरेट
राइट।
मॉडल।
ठीक है ठीक है, तो एक उसका भी है आपका VN?
नहीं सर, वो भी जनरेट कर सकता हूँ भी अगर आप चाहें तो।
नहीं, इन द इंटरेस्ट ऑफ टाइम, आप, बट आपने टेस्टिंग की भी है आई गेस।
इस टेस्टिंग की हुई है, अब उसका मेरे पास ट्रैक नहीं है उसका टेस्ट का।
ठीक है, तो यू सेड कि इट विल बी लेसर एक्यूरेट।
यस।
व्हाट वुड दैट मीन?
लाइक वो फिर मे बी कुछ ऑब्जेक्ट्स लूज कर जाए, लेकिन उसको फिर बचने के लिए ना हमने वो ये जो पहला हाइपोथेसिस हमारा वो यही है कि पहले जो पहले मॉडल की लर्निंग है हमारी V5 लार्ज की, उसकी आउटपुट्स हम ले रहे हैं, हार्ड लेबल्स ले रहे हैं इंस्टेड ऑफ सॉफ्ट लेबल्स, उस पर ट्रेनिंग कर रहे हैं। तो इट माइट इम्प्रूव इट्स ट्रेनिंग एज वेल।
ठीक हो गया। चले, एनीथिंग एल्स टू डिस्क्लोज और डिस्प्ले?
नो सर,
राइट, तो
दैट्स इट
हम
फ्रॉम
फिर
माय साइड।
कोई क्वेश्चंस ले लेते हैं। महमूद, आई थिंक वुड लव टू आस्क अ क्वेश्चन, क्योंकि वो भी डीप लर्निंग में मैं सुना काम कर रहे हैं। महमूद कह रहे हैं कि क्लियर हो गया सब कुछ। आ, ठीक है। एनीवन एल्स? मुसव्वर या साबिर, कोई मुश्किल सवाल पूछना चाहें आप, काजी को फंसाना चाहें? नाउ इज योर टाइम। लो जी, आई थिंक सारे आपके सपोर्टर्स आए हुए हैं इस वक्त, तो नो दुश्मन पार्टी है। ठीक है काजी,
यस सर।
तो थैंक यू सो मच। ये रिकॉर्डेड सेशन आई थिंक फैकल्टी और बाकियों को मैं शेयर कर दूंगा एज सून एज पॉसिबल। इट वाज अ प्रीटी गुड वर्क, बट स्टिल लॉट्स ऑफ थिंग्स टू डू, राइट?
यस सर, ऑब्वियसली।
राइट राइट। चले, गुड लक विद दैट, तो फिर इंशाल्लाह मुलाकात होती है।
ओके
अल्लाह
सर।
हाफिज काजी एंड एवरीवन, थैंक यू फॉर कमिंग। अल्लाह हाफिज।